Alright guys, let's take a look at this circuit, and specifically what we want to do with this circuit is use superposition to obtain I naught. Okay, so you want to use superposition to obtain I naught here. Okay, so just remember, superposition is when we take the independent sources and turn them all off except one and solve for the thing that we're looking for, in this case the current. So what we're going to do is we're going to turn off, for instance, we'll turn off this 4 amps and this 2 amps, and then keep the circuit with the voltage source here and solve for I naught. We'll call it I naught sub 1, and then we'll go ahead and turn off the 12 volts here and the 4, and we can even say this one as well, 2 amps, and then keep the 4 amps on and solve for I naught, we'll say sub 2, and then we'll finally turn off this 4 amps and the 12 volts and keep the 2 amps, and then solve for I naught sub 3, for instance. Okay, and so the goal is to solve for I naught 1, I naught 2, and I naught 3, and then superposition says, okay, if we do that individually by turning off each independent source, okay, we can at the end add all of them up to get I naught. Okay, so it's kind of like reverse engineering in some way. Okay, so how do we do this? Let's go ahead and start with the first one, which is the easiest, where we want to turn off. We'll go in here and say, okay, I want to turn off this guy, I want to turn off this guy. So how does the circuit look like? If I do that, actually let me back up a little bit. Let me just back up and give you a quick review of current division, because we're going to be doing a lot of that in this problem. So current division, okay, and current division is when we have some source. Let's just say we have a voltage source here, and we have 2 resistors in parallel, R1 and R2, and we have a current coming in this way. We have a current coming branching down here, I1, and a current I2 down here. Okay, so current division says I can find I1 by taking R2 and then taking the sum of R1 plus R2 times the original current, the source current I, and then the same thing for I2, except now we take R1 instead of R2 and say R1 plus R2 times I. Okay, so just keep that in mind, because we'll be using this in this problem a couple times. Okay, so current division. So let's go back to this problem here. So we want to redraw the circuit, and the way we draw it, say, okay, I want to keep my voltage source here. Let me redraw it a bit better. Okay. I want to keep my voltage source. But now what we're going to do is we're going to get rid of the 4 amps, so that's going to be an open circuit. We'll keep everything the same, all the elements are going to stay the same. We have a resistor there, a resistor here, and a resistor here. Okay, again, the 2 amps is going to go away, the 4 amps up here is going to go away, because they're both going to be open circuits, and we're left with, in this case, we're just going to call this I naught sub 1. Okay, where this is 12 volts, 4 ohms, 3 ohms, 10 ohms, 2 ohms, and 5 ohms. Okay, so this is a pretty simple circuit. What we're going to do is we're going to take these 3 guys, because they're in series, and just add them up. And if we add them up, we get 10. Okay, so we can quickly redraw this circuit here. We can quickly redraw the circuit. 10, this is 10, this is 4, and of course immediately you see that these two are in parallel, okay, and we can do the equivalent, which is 10 times 10 over 10 plus 10, which gives us 5 ohms. Okay, so now we have 5 ohms in series with 4 ohms, and technically our circuit can be even further simplified to something like this, where we have 12 volts and we have 9. Okay, and this is simply our I naught 1, and so now we just need to solve for that. Okay, well, this is V equals I R. Okay, and then we, or where our I is I sub naught 1, we'll just rearrange it and we get 12 divided by 9. So we solved for I naught, and we'll just keep it like that. We'll just say 12 divided by 9 amps. You can plug it into your calculator later. Okay, so that was the first part. So we turned off the current sources, all the other independent sources, and kept one on. Now what we're going to do is we're going to turn off, let's turn off the 12 volts and the 2 amps. Okay, let's turn those off and see how the circuit looks like. So now we're going to turn off the 12 volts, so that's going to be a short circuit, and then we can redraw the circuit. We'll redraw it like this. This is going to be 4 ohms, 10 ohms. Here, this is 3 ohms here. Again, we're still turning off the 2 amp current source. So we got 2 and 5. So now this is our second circuit, and here we're going to call this I naught 2 for the second current that we're going to solve for. Okay. I'm going to put another current down here because we're going to be using this later. I'm going to call this I sub 1. We'll use this later to determine some of these currents. Okay, so what we can see here is that, again, the 2 and the 5 are in series. Okay, so this becomes 7 ohms, and just add them up. And then the 4 and the 10 are in parallel. So we just multiply them and then add the total. 4 times 10 over 4 plus 10, and we'll just simplify, we'll just keep it in fraction form out. That's 40 over 14. Okay, and then if we simplify the circuit, we add all those. So again, I'm going to draw my 4 amps, 3 ohms here. Okay, and then what we can do is say, well, we have, so we said this was 40 over 14, this was 7. Okay, that guy. This is 40 over 14. Okay, these guys are in series, so we can just add them up. So 40 over 14 plus 7, and we keep it in fraction format, we can get 69 over 7, and then we redraw this again to get a better visualization. So now what we have is we have a current source, we have a current source of 4 amps, we have our 3 ohms here, and we have another resistor here, 69 over 7. We have this current coming down here, a branch current going this way, a branch current going this way. We can call this I1. Okay. So now, based on this, we can do current division. So we know I1 is equal to R2 over R1 plus R2 times I, where this is going to be our I, and this is going to give us I1 equals 3 over 69 over 7 plus 3, all this multiplied by 4 amps. Again, we'll keep it in fraction format. That's going to give us, if we compute it, 84 over 90. Okay, so now that's I1. But what we want is, so this gives me I1, which is this guy, but what we really want is I sub naught 2. Okay, so then we can come back to this portion here, and then we can further simplify this equation. You take this current division, I can say I naught 2 is equal to, we got the current going the opposite direction, so minus 10 over 4 plus 10, all that times I1. Okay, so we have just 2 branches here, and you have a current going in. Okay, so we can plug in I1 into this equation, and then we get minus 6 over 9. Okay, so now we have IO2 is that. So we've got I, so we solve for IO1, we solve for IO2, now we need to get IO3. We'll come back up to the circuit here. Now we're going to turn the 4 amps off, we're going to turn off the 12 volts, and then we're going to keep the 2 amps on. Okay, and then let's look what the circuit looks like. And that's what superposition is about. You turn off all the independent sources except one, and you solve for what you're looking for. In this case, we're looking for the current. In some situations, you might be looking for the voltage, so you'd solve for V1, V2, V3, depending on the number of sources in the circuit. Let me go ahead and redraw the circuit again. Redraw it, and then we have a resistor here. So we're drawing it again, so we got our 4 ohms here, our 10 ohms here. We have our 3 ohms, 3 ohms, yeah, and then we have a 2 ohms. 5 ohms. And now we have our current source up here. And this is 2 amps. And we're going to call this IO3. And then we're going to call this coming in this way I2, coming from that 2 amp source. We look at here, these guys are in series, we add them up, that one gives us 5. These guys are in parallel, we do the same thing as we did last time. 20 over 7 or 40 over 14 is what we said last time, it's same thing. 20 over 7. Okay. And then both of these, we can add them up because they become in series. So then we get a new circuit where 5 plus 20 over 7, 5 plus 20 over 7 will give us, keep it in fraction format, 55 over 7, and that's going to be our new circuit here, or a more simplified circuit. And we're going to keep these guys in parallel just because we want to get the current using current division. Where this is 55 over 7, and this is going to be 5, and this is going to be 2 amps. Okay. Remember we said our current is coming this way, so we got current this way, and it's going to branch off into both of these branches here, and here. I can do current division to solve for I2, and that's going to be 5 over 5 plus 55 over 7 times 2 amps. So that's going to give me I2 equals 7 over 9. Okay. And then we'll go back to this here, and then we'll solve for I03, which is going to be 10 minus 10 over 10 plus 4 times I2, just going to be feeding in there, and that's going to give us minus 5 over 9. So I03 is 5 over 9. So now we have solved for I03 as well. Now we just need to sum them all up to get I0. Okay, so now I0 is just going to be I01 plus I02 plus I03, and that's going to be 12 over 9 minus 6 over 9 minus 5 over 9, which gives us 1 over 9, which is 111.11 milliamps. Okay, and that's how we use superposition to solve for the current of this original circuit here. Okay, again, the process is you take your independent sources, you turn off all your independent sources, keep one on, solve for it, the current, and you just do that each time, and depending on the number of sources that you have, independent sources you have, you're going to have a bunch of components, and you just sum them all up, and that's how you solve for this problem using superposition. Okay, thank you. I'll post another problem in the next video.